Welcome to People, Places, Planet Pod, the official podcast of the Environmental Law Institute, a nonprofit, nonpartisan organization working to ensure a healthy environment, prosperous economies, and vibrant communities founded on the rule of law.
Welcome to this installment of the People, Places, Planet miniseries celebrating the winners of the 2023 National Wetlands Awards. My name is Georgia Ray, and I'm your host. The National Wetlands Awards are presented annually to individuals who've excelled in wetlands protection, restoration, and education. Through coordinated media outreach, educational events, and an award ceremony in Washington, D.C., awardees receive national recognition and attention for their outstanding efforts. Today, I will be speaking with Bingqing Liu, this year's Scientific Research Award winner. Dr. Liu is a research scientist and deputy director of the Restore Act Center of Excellence for Louisiana at the Water Institute. She has recently focused on coastal carbon capture, examining the carbon sequestration potential of coastal restoration projects included in the Coastal Master Plan. By developing an analytical framework, Bingqing and her team have provided insights into the potential of wetlands to sequester carbon over time. This research serves as a crucial foundation to inform future policy decisions on coastal restoration to advance climate mitigation and ecological restoration and protection. She has also been closely working with Chevron on a blue carbon project to improve offset-enabling technologies for blue carbon sequestration in marsh mangrove ecotone. Bingqing led her team to use machine learning techniques of remote sensing imagery combined with wetland ecosystem modeling to protect future wetland habitats, including black mangroves and smooth cordgrass, as well as carbon sequestration in these habitats in the face of climate change. She earned her PhD in Oceanography and Coastal Sciences at Louisiana State University and an MS and BS in Environmental Sciences at Shanghai Ocean University. Bingqing, thank you for joining me.
Thank you for this great opportunity. It's my great pleasure to share my story here.
And please get us started. Can you give us a snapshot of your wetlands work?
Sure. As many people know that Louisiana has an extensive coverage of wetlands, which provides me a great opportunity to study their important role in carbon capture and storage. The wetlands have the great capability to capture the carbon dioxide in the atmosphere and sequester carbon in their biomass and lock up the carbon in the soils for long term. So wetlands are well known as natural solutions to support the mitigation and adaptation to the climate change by reducing the concentration of carbon dioxide in the atmosphere. In my wetland work, I specifically focus on quantifying the carbon sequestration potential of the wetlands over time. We conduct extensive field work and utilize advanced remote sensing techniques to quantify the carbon sequestrated in plant biomass as well as the soils. However, our pursuit of knowledge does not end there. We have embraced the cutting-edge technologies and leveraging the power of machine learning and deep learning to analyze extensive data sets and drive our coastal wetland model. So the integrated approach enables us to precisely quantify the carbon captured and stored by wetlands, not only for the present conditions, but also for the future projections in response to a changing climate. So this knowledge is crucial for climate change mitigation strategies and guiding future wetland conservation and restoration efforts. We are committed to advance our understanding of wetland carbon dynamics and incorporating this scientific information into decision-making process to ensure the long-term sustainability of this remarkable wetland ecosystem in the face of environmental challenges.
Yes, you phrased that so well, how important this work is. So what inspired you to get involved with the work in the first place?
Thank you. This is a great question. And I think the inspiration behind my wetland work is a combination of personal experiences and the remarkable restoration and protection efforts undertaken by the state of Louisiana. During my time studying in Louisiana for my PhD, I had the privilege of witnessing the incredible natural beauty and the ecological significance of Louisiana's wetlands. And these wetlands are not only globally recognized for their biodiversity and cultural heritage, but also play a very important role in supporting the coastal communities and acting as a natural buffer against the storm surge and the flooding. However, Louisiana's wetlands are also on the front lines of climate change, facing a lot of climate-related challenges, including sea level rise and the cost of wetland loss. How to respond to these threats has been an important inspiration for me to initiate my wetland research. So during my study, I think state of Louisiana has shown tremendous commitment to preserving and restoring wetlands. I've seen our state agency, Coastal Restoration and Protection Authority, has implemented and developed the Coastal Master Plan and outlining the actions to sustain our coast. And this is another great inspiration for me. And after my graduation, I joined the Water Institute. I have had the privilege of working with an exceptional team at the Water Institute where we employ diverse approaches to protect and study wetlands based on science. It let me have so much passion to continue my wetland work there. And at the Water Institute, we also actively engaging with local communities, state managers, policymakers, and other stakeholders. And these partnerships have been very important in driving our research forward and ensure that our work has a meaningful impact on wetland conservation and restoration.
I'm so glad you mentioned the meaningful impact you wish to have, because I want to talk about how your work might differ from some of the other awardees today. So you're the Scientific Research Award winner, and how does that make your work unique or different from others acting in the wetland space?
This is an excellent question. I think when considering what makes my work unique, it goes beyond the technical process of conducting research projects and producing the scientific research. We place a very strong emphasis on the applied science and the integration of scientific findings into the decision-making process. One key aspect of our approach is the concept of a co-production of science. This involves collaboration among the scientists, the managers, and the policymakers to address complex wetland challenges by bringing together the diverse perspectives and expertise. Different knowledge systems co-production allow us to explore these issues more comprehensively and develop the solutions that are not only scientifically sound but also socially and politically feasible, so that we can target the wetland management needs and seek to align our wetland research with practical applications. So I would also like to mention that co-production is an iterative process that involves ongoing feedback and adjustments throughout our research journey. We continually adapt and refine our work to make sure it remains responsive to the needs and the evolving context of our partners and the stakeholders. And this iterative approach leads more effective and relevant outcomes.
So you've talked a little bit about the approach you take in your scientific research, but I want to talk too about the substantive part of your research. So you also have mentioned Louisiana already and the important role that Louisiana plays in protecting the United States coast. So how did undertaking your PhD work and your current work on coastal carbon capture in this Louisianan context add a richness to the work? And what can Louisiana as a case study teach us about the importance of coastal carbon capture?
This is a great question. I think I have a huge advantage to conduct my PhD journey in Louisiana because, as I mentioned, it has extensive coverage of wetlands in Louisiana. It provides me a great privilege to conduct a field work there and to understand the carbon dynamics in wetlands there. And my background is remote sensing, and I use a lot of remote sensing data to study the coastal waters as well as wetlands. And I think it's a perfect combination for the field work and the remote sensing so that I can create maps, and that really gave me a lot of passion to look at the wetland carbon dynamics at a larger scale with higher spatial temporal resolution. And all of this great information and can help us to drive the model to predict the future. And that's very important for us to create the meaningful climate change strategic plans to protect our wetlands.
Another project you've been involved in is the Blue Carbon Project. That sounds fascinating. What was the interconnection between offset technologies, marshes and mangroves, and that same machine learning-based remote sensing for that project?
Yes, this is a very interesting project. So we are collaborating with Chevron, and they also have a great goal to achieve the carbon neutrality and support the scientific community to do the work and support the carbon neutrality. And the work we have done on this project is study the carbon sequestration mainly for the black mangrove habitats, which is a little bit different compared to the salt marsh. And they have the woody biomass and they can sequester more carbon in their above ground biomass. And there's a very famous place in Louisiana where the large amount of black mangroves are expanding into the salt marsh, and because of the warming temperature. And so our focus of this study is trying to quantify the carbon in the black mangrove biomass and the carbon locked up in the black mangrove soils, and as well as how it behaves in the face of climate change. So in the model, we also add in some restoration projects to see with and without restoration activities, what is the carbon benefits for future projections in the face of climate change. And the results tell us a very interesting story. And the marsh creation projects that with more black mangroves give us more carbon benefits compared to the salt marsh in that study area. But there's still a lot of uncertainties in this type of study. And our next step would be collect more field data to reduce the uncertainties and to well inform our numerical model in this area.
Well, I'm excited to see that when it comes about. And thank you so much for talking with me today.
Thank you so much for the great questions. And it's my pleasure to share my wetland work story here.
Thank you for tuning in to People, Places, Planet Pod, brought to you by the Environmental Law Institute. We would like to hear from you, so please send us your questions, comments, and ideas to podcast@eli.org. And if you're interested in learning more about our work, attending one of our events, reading our publications, or becoming a member, please visit our website at www.eli.org.